How did ancient aqueducts maintain precise gradients? Imagine a city thousands of years ago needing a steady flow of water from distant mountains or rivers. How did they make sure the water moved smoothly without stopping or flooding? That's where the skill of ancient engineers really shined. They used clever tools and careful planning to keep the water flowing at just the right speed. The key was maintaining a gentle, consistent slope. If the slope was too steep, water would rush too fast and cause erosion or damage. If it was too flat, the water might stop or flow very slowly. To get this just right, Roman engineers started with detailed surveys of the land. They used special instruments like the groma, which helped measure right angles and straight lines, and the chorobates, a leveling device with a water trough that showed when a surface was perfectly horizontal. These tools allowed them to measure land elevations accurately over long distances. Once they knew the land's height differences, they planned the aqueduct's path with a very gentle slope. For example, the famous Pont du Gard had a gradient of about 34 centimeters per kilometer, meaning it dropped only 17 meters over 50 kilometers. That's a very slight decline, but enough to keep water moving steadily by gravity alone. To keep this slope consistent during construction, Roman engineers sometimes used the aqueduct itself as a reference. They built sections and checked the slope as they went, making small adjustments to stay on course. This way, errors didn't accumulate and the gradient stayed precise. The channels were built with flat bottoms and waterproof linings made from materials like pozzolanic concrete, which reduced friction and water loss. They also used arches and vaults to cross valleys, all while keeping the gentle slope intact. When terrain was steeper, engineers added stepped cascades or settling tanks. These slowed the water, prevented damage, and helped aerate it, improving its quality. This ability to keep a precise gradient was a huge step forward in urban development. It allowed cities to have reliable water supplies for drinking, bathing, irrigation, and sanitation. The engineering behind it showed how careful planning and smart use of tools could change the way humans built and managed their environments. In the end, ancient aqueducts stand as a testament to human ingenuity, showing how precise measurements and thoughtful design can solve complex problems and shape thriving communities.